if you have a good sense of how to do all the other things that we've done on the calculator, then you shouldn't have any trouble with this. But if you've been kind of slacking off with calculator stuff, then you're going to be in a world of hurt when it comes to this, because you're going to have to learn like everything that came before this in order to understand this. All right. But in terms of the topic itself, just a little background. It's something that honestly, up until a few years ago, wasn't even taught in this course. And the first time I ever taught it was in a course, AP statistics. So something that, a course that you wouldn't even take until senior year, if that, because it's an elective. I didn't even teach it in the college level stat courses. Then they put it in this course, and then they said that they're going to be taking it out of this course. So I don't know really what they're thinking in terms of like what their motivation is behind including this topic, but it is actually a pretty important topic. So I just wish they'd kind of make up their mind as to whether or not they want you to know it. I think it's a useful topic. So the reality is, even if it wasn't in the curriculum, I'd probably cover it anyway. Right? What it is an extension off the concept of linear regression. So specifically linear regression. So not exponential, quadratic, or anything like that. It's specifically the line of best fit. Just understand that they can ask you about a linear regression equation in a bunch of different ways, but they all mean the same thing. All right? What is the one thing that you notice is in common between these four ways of representing the same idea? Line. All right? So you gotta be careful about it, because they would say something like, find the line that best fits the data, and people would come up with exponential or quadratic models, and I'd kind of shake my head at that, and I would say, listen, there's a word in there. It's like kind of screaming at you. It says line. If it says line, it's not saying parabola. It's got to be a line. All right. If it says curve, find the curve of best fit, then it could be exponential, quadratic, whatever. But it could also be a line, because it's kind of weird to think about it. But a line is a special type of curve. You're like, but a line isn't curvy, so how could it be a curve? The condition is that the rate of change is constant from one x value to the next. All right? So you got to think of the line as falling in the category of a curve, but a curve does not fall into the category of a line. All right? So it doesn't go both ways. Anyway, so this whole blurb here talks about the context of the data, and then it seems like they did a lot of the work for you, but they actually barely even scratched the surface. So we came up with the line of best fit, just written in a slightly different form. They plotted the data in the form of the scatter plot. They plotted the line of best fit, and now we have to do something else with that. That something else is finding what we call residuals. A residual is the difference between the observed y value and the predicted y value. Now, this lesson is broken up into chunks, but I'm going to show you how to find them all in one shot, and then you can kind of pick out the ones that you need depending on the situation. All right. So the first step, whenever you're given a set of data, I think you know what that first step is. Type it in your calculator. Stat edit. Pop these bad boys in there. That's kind of a step that I don't think I ever really need to write down on paper anymore. It's like, you're given data, put it in your calculator. All right, double check. Also another step that I don't think I need to write down. You want to definitely double check, because if you're doing all of this work on your calculator, the only way you're going to screw it up, assuming you know the process in general, is if you type in a data entry incorrectly. All right, so.
What's the negative symbol? I hit the negative symbol for every single one.
Every one of them?
Or, yeah.
Wow.
My finger is just always doing this.
Ah.
Instead of hitting the decimal.
Muscle memory. Just gotta gotta stretch those ligaments. To give you a little more flexibility to get it over.
Yeah, it's just, I don't know why I did it. 'Cause it rests here. whenever
Maybe.
I'm just not doing it.
Maybe like dexterity exercises. I realize I'm very slow. I'm not as nimble with my dexterity as I used to be. I used to be like, now it's like, all right, so your data's in, hopefully. Hopefully it's also in correctly. All right, so before I actually get into the calculator approach, I'm just going to show you what a residual is visually. It's nothing too crazy. All it is the vertical distance between a data point and the line of best fit.
Oh, don't you want it?
That's poor quality.
You want it to be a small number.
Generally, you want it to be a small number. There are exceptions. If you're trying to prove somebody wrong, that's the exception. Sometimes you want to go the other way and say,
Or if it's like deaths per year. What? You don't want it to be like above.
yeah. Generally, I mean, it's like, depending on the context of the situation, I mean, it's kind of morbid, but I use, in my college class, I try to stay away from it here because it offends, but I use infant mortality as a data set, because it's a way of, like, the difference between a first world, second world, third world country.
Yeah.
So infant mortality is one of the measures by which you could determine the world of a country. So a high infant mortality rate means what?
Low.
It's a bad thing, right? So, but if you have like a high average in a class, that's a good thing, right?
Yeah.
So I break it down to keep it a little bit less morbid. I equate, basketball scores with good and golf scores. So the higher the basketball score, the better you are, right? Like the higher the golf score, what? The more terrible you are. So if you scored 50 points in a basketball game, high school basketball game, 50 points, actually NBA basketball game, doesn't even matter. You scored 50 points, good player, bad player?
Sick player.
Like awesome player. All right, they take note of when a person scores 50 points or more. If you
Score
get
50 players.
if you get a 50 in nine holes of 9 holes of golf,
You are insane.
You're tired.
you're probably not that
You
good.
hit it in the water every time.
These are the distances from your data points to
You're like,
the line.
and then you're under the sea.
I don't know if you could.
Sand trap.
That's what a residual tells us.
Rough, right up bed.
So, what do you think happens when our residual values are really large?
They're terrible. Positive. It's not very little big number of values.
Yeah, the correlation isn't going to be that good. It's not going to be a great fit. The data set and the line aren't going to correlate very well with one another. All right. Now, the line may be the best fit option for the data. It just means that there's a lot of variability. It's telling us that we're going to have to be careful with any conclusion we draw from this particular model. All right. If your residuals are very, very small, that means the data points are very tightly grouped around the line. All right. So that's all we're doing here is we're looking at deviation from the line of best fit. All right. If you have a data point that is extremely far away from the line of best fit, we call that an outlier. All right. So we do a little bit more with that in AP Stat and Province Stat. It's just if it's far away in the Y direction, we call it an outlier. If it's far away in the X direction, we call it an influential point. But that's not something you need to know.
So those two are outliers.
Those two could be outliers. They could be outliers depending on the context of the situation. All right. Good.
Literally the weight of a curve.
No, it's how a car's weight at rest. Because they have
So when it's curved.
different weights depending on different circumstances. But really, if you think about it, you're talking about fuel efficiency or fuel economy, miles per gallon. this one seems to be a little bit out of whack, the third one. So it's a middle of the road weight, but the fuel efficiency isn't really that good compared to what it ought to be. I think that's the one, yeah. So you might be wondering, well, what's going on there, right? So let's say I have a Honda Civic. I'm supposed to get 35 miles per gallon, right? Let's say I only got 27 miles per gallon. What do you think was happening? Is it because of the Civic or is it because of me?
Because of you, you're driving.
I'm driving too fast, right? Or driving in such a way that I'm using more gas. Maybe I got the air conditioning blasting, you know, and I'm like gunning it instead of, you know, stop at a stoplight. Yeah, you got a lot of stuff in the car. You got a ton of things in the car is weighing it down. You know, a lot of different possible. Long distances, you're putting a lot of mileage on the car, that could impact things, depending on whether it's highway versus local roads.
Kayak on your roof.
A kayak on your roof, wind resistance, anything like that could impact your fuel economy.
Now we're doing physics.
Right, yeah, so there's a lot of stuff that could go on in this situation. All right, but what we want to do is we want to find a nice, easy way to find the difference between the observed values and the expected values. These, or predicted values, these values here are observed. All right, observed just means that these are the things that happened when you were collecting the data. All right, so let me put it to you this way. If I flip a coin, what are my chances of getting ahead?
50%.
50-50, right? All right, so if I flip a coin twice, how many heads should I get? One, right? That's my expected value of 1, right? Now, if I actually flip the coin twice, does that mean that I'm guaranteed to have 1 head? No, I could have 0 heads, I could have 1 head, or I could have 2 heads. All right? Whatever I get when I actually flip the coin twice is my observed values. What I should have gotten are my predicted or my expected values. All right? In this context, what we're doing is we're letting the calculator figure out for us what we should get if we used our linear regression model. All right? That's where the calculator comes into play. All right? So, data gets plugged in. We already did that. What we're going to do is run a linear regression. So they gave us the equation, but that doesn't really help us very much. So I'll actually write it. I said I wasn't going to, but I'll write it. Input data. And then what we're going to do is and find the linear regression equation. I'll write lin regs to be specific. Lin reg equation. All right. All right, and just understand again, you could be told to find a linear regression equation, line of best fit, least squares regression line, or a trend line. They all mean the same thing. And you got to know the difference. On a test, you can't say, trend line, is that the same thing as a regression equation? I can't tell you. All right, that's what you're being assessed on. All right, but it is, yeah. And again, test would be the regions. So I'm not even going to be there to tell you. Ask the gym teacher. He'll tell you. Yeah, I guess so. They both have line in it. And that's not a knock on the gym teacher. That's just like, they'll just use common sense. Does it have the word line in it? Yeah? Okay, good. But they can't even tell you that, all right? English teacher, social studies teacher, administrator, anyone, guidance counselor. All right, so let's get out of here. Stat, calc. Option 4. L1, L2 are my defaults.
Alpha trace enter.
Alpha trace enter. Store regression equation in Y1. In a lot of other situations, this step was a luxury. Now it's a necessity. If you don't do it here, it ain't going to work. All right, you will never be able to get a residual question correct if you do not follow this step. But since we've been doing it for every situation, it should be muscle memory at this point. All right, calculate. Error data type. So I screwed something up. Classic Bob. Yeah. It's an old TV show. Type my data in. Stack calc 4. Oh, Here's why. It's weird. If your calculator worked, if you got it, then you don't have this quirk on your calculator. I don't know why it happens like this for some cases. If you have something stored in Y1, for some reason, in some cases it doesn't work. I don't know why. Honestly, I have no interest in reading the manual to figure out why. But clear out whatever is in Y1. I do not. Bathroom if you need it.
Ever since the kids stole them.
Ever since people rudely stole all the tissues and then used them to blow their nose and like wipe their faces and then they threw them all away rudely. I don't have any more tissues.
Probably the computer on some operating systems is unable to replace values without your acknowledgement.
Yeah, probably.
Is it okay if the A and B values switched on the calculator?
That means you use the other Linear.
Did you use Stack Calc 4 or 8?
I use stack calc.
It really doesn't matter as long as you have the same values.
I use 8.
Oh, you use 8.
That's why I use 8.
Okay, so your answer is consistent with the one on paper.
Yeah.
So, perfect.
Yeah, so
As long as you follow the model at the top of your screen, you're good. Okay. So if you're good up to this point, that means that you know all the stuff that we already know, which is cool.
Yes.
It also means you haven't learned anything new this class period in terms of the calculator, so you got to stay with me here. All right, so go back into Stat Edit. You're going to go into L3, which means bring your cursor right on top of L3. Very close. That's part of it. Go to L3, hit enter, and then type in Y1 of L1. What? That's crazy talk.
so,
Why would
okay.
we do that?
So you're
Let's think
multiplying-
about what it is.
You're multiplying every single L1 value by the line of thingy.
Kinda.
Wait, can you do it? Wait, what did you type?
So enter. Go on to the L3. I'll tell you right now, if you get an error message, it's because you did this. If your cursor is right there in that first cell and you hit enter, if you have L3 of 1 on the bottom, you're already doing it wrong. Right onto the L3, hit enter. Y1, how do we get Y1 again?
Second trace.
Alpha trace.
I thought you said L1.
Open paren. How do we get L1? Second one. Close paren. Then hit
Get a
enter.
bunch of numbers.
And you get a bunch of numbers.
I did
There
something
you
wrong.
damn numbers.
So what
There
you
are
did,
numbers.
I did wrongness, I think.
Hey.
You have completely different numbers.
Completely different numbers?
By that I mean the decimal places are off.
Just the decimal places?
Just the decimal places. Nope. And 28, I have 29.
I have 258.3.
You did something wrong.
What? How did you do
Yeah, that's where we're at with this.
I got the right number.
I'm going to double check my data again here.
I got the right number. I got the right number.
Oh, I did point. Yeah, I see where I did wrong.
Yeah.
79, not 0.29.
Okay, now try it.
Yeah, so again, folks, really, once you get the process down, the only way to screw this up is if you type the data in incorrectly. All right? So then what you want to do after you've gotten the correct values in L3 is you want to go to L4. I know. Go to L4, hit enter. Now, the rule for a residual is observed value minus predicted value. The observed values are in L2.
L2 minus L1.
L2, I wrote a 4 for some reason. L2 minus L3. But it's still not a 4, so either way, you're ahead of the game. So go to L4, hit enter, type in L2 minus L3, and then hit enter again.
should it be the absolute value of?
No, because negatives are going to give us direction.
Ah.
So I can't type in like y1 times l1. It just goes like an error.
Did you do it on L3?
Yeah.
All right, I'll take a look in a sec. So L2 minus L3, enter.
Wait, it's not there.
Scroll over.
Yeah, I got I just wanted to make sure, Heather.
All right. So part A is asking us whether the residual for the car whose curve weight is 25.33 will be positive or negative. Well, we figured out what all the residuals would be. So it's just a matter of getting the corresponding residual to 25.33. That's the first entry, which is positive, but they asked roughly what it was. So we'll first state that it's positive. And then we're going to say it's approximately 3.1. Because they said roughly. So we have a little wiggle room there.
What is what is like the, what's the unit?
Approximately, yeah.
Is there no unit?
Oh, there. Well, it's therefore, yeah.
Approximately is a tilde.
Yeah, it's the double tilde for approximately. No, I might have misspoke. I think I said approximately when I meant to say therefore. So the therefore, the triangles for therefore, the fact that I rounded it to 3.1 is to address the fact that we're allowed to do it roughly. All right. So then one sec, but the second one is asking us for a negative. Well, it's not asking us for anything. It's asking us to determine whether it's positive or negative. It is negative because 27.79 corresponds to the negative 6.1. So therefore, we're looking at about negative 6.1 exactamundo. All right, Reagan, another question.
How do you know like which column to look for?
They told us 27.79. So I identify row 3.
You have to go all the way to the left.
These are the observed values. These are the predicted values, and these are the residuals.
I still don't have the right.
Yeah, there's several groundhogs outside.
There was 3 baby ones.
It's Groundhog Day.
Apparently.
February.
But you know what's really cool? They have wildlife at zoos too. So if you are interested, you can go there. So I'm just filling out this table based off of what we came up with on our calculator, which we now don't really have to bother with figuring out because we've already done it. All right, so 3.1. It seems like they're looking for us to round to the nearest hundred, so that's what I'm doing. It says it here. It doesn't say it for the residuals, but I mean, if we're rounding these to the nearest hundred and then subtracting, we're going to get an answer to the nearest hundred. So we'll just continue rounding to the nearest hundred. So 0.57. 1.43, 1.02. Now, if you compare this with a diagram from the previous page, those little vertical line segments that we drew, you should see a nice size relationship corresponding with these values. All right, the one that was really lengthy below the line of best fit should correspond with the 27.79. The one that was fairly lengthy above it should correspond with the 25.53. Everything else should be fairly close to the line of best fit. All right. So, prediction. What does the least squares line predict for the fuel efficiency of this car? That's the car that has a curb weight of 31, well, a curb weight of 31, but it's in hundreds of pounds, so 3,100 pounds. So all we're looking for is Y of 31. I want to do that in my home screen because I don't have to mess around. I don't want to have to actually deal with the table. I don't want to hit second graph and scroll through. So what's a technique in my home screen that I could use to figure out the Y value that goes along with the next value?
Great question.
I'm very proud of that particular question.
Solver?
No, because solver is when you're trying to find X that goes with a Y. You could do that, sure. There's a slightly easier way.
Oh, store Y as a value and then do things. You hit Y1, then you select alpha trace, and then you hit Y1 of X.
I can't see because the thing away.
Alpha trace y1,
Can't read.
type in the 31. We stored the equation in for y1. It's there already. So now if I do y1 of 31, it's going to run the numbers for me. So 31.22 miles per gallon. All right. So then the follow-up question here would be, would you be surprised if the actual fuel efficiency of this car is 29 miles per gallon? So somebody got a car that has a curb weight of 31, so 3,100 pounds, right? And the fuel economy was supposed to be 31.22, but it turned out it was 29. Are you shocked?
No.
No.
Oh, isn't 3 the difference it can be?
No. It has to do with just context of the situation. Because driving habits.
This is curve, right? This is not linear.
What's that?
This one's not. That makes no sense. You feel me?
Impact miles per gallon, MPG. Oh, that's a lovely question. Does anybody want to help Peter understand that one? How many miles per gallon does a Tesla get?
0, because it doesn't have any gallons.
Yeah, how many miles per gallon does the Professor get? That's a good one.
It's Mr.
MC.
Mr. C's car.
That
The guy known as MC.
you should remind me to make that a trick question on a test or something.
Oh, see, that's yeah.
Yeah, he's my go-to for this class. So
Do you like him?
I do. He's one of my good friends. I'm sure he likes you just fine.
I don't think he really hates me.
Oh, so he probably doesn't like you.
You dropped out of class?
All right. So the last thing we have to do here is create a residual plot and analyze it. And this is actually the last thing we have to do in the course. So yeah, I know. So they told us that a curb weight has a residual of 3.11, but we knew that anyway. So what we need to do is plot all of the other residuals against their curb weight. So a residual plot is always x value, so x versus the residuals. All right, always. All right, so you could get it from your table. If you didn't actually write it down, you could get it from your stat editor, your L1 values against your L4 values. All right, you could do it that way. All right, but since we wrote it all out up here, we might as well take advantage of that information. So we're just ballparking it. So we got the first one, 26.94 is roughly 0.57. So a little bit less than 27 is going to be a little bit more than a half. So we're just going to eyeball it. So like, meh, probably a little bit more closer to meh. All right. So then 27.79. So X values against residuals. So a little bit less than 28, a little bit less than -6. So we're looking at something like there. A little bit more than 30, a little bit less than 1.5. And then the last one, a little bit less than 32.5, to a little bit more than 1. I forgot. A little bit more than 1, right? So like here-ish, something like that. All right. So you could, if it looks like it's too small, you can darken it in a little bit. And also, if you feel like you're not close enough to what the actual value should be, you know, make them darker so you cover more area, or bigger. So, well, yeah, the answer is somewhere in there. It's harder to take off credit. Yeah, You missed the point. Make the point bigger.
But
All right.
just look at the entire graph.
just
Nothing you can
just
do.
shade the whole thing in. Yeah, the answer's in there somewhere.
The little white spot is the small piece that I missed.
Exactly. Is there a pattern of the points in this residual plot? Do you see a pattern?
No.
No pattern. All right. When a pattern is observed in a residual plot, that means a linear regression model is probably, that's one of our favorite words in stats, probably not appropriate for your data. So what we're going to assume that means, because context is important, but if you see a pattern in a residual plot, it means a linear regression is not appropriate, which also means that if we don't see a pattern, therefore linear regression is appropriate. What?
I'm confused.
Excuse me, what?
If there's a pattern, then we're saying linear regression is not appropriate. But if there is no pattern, then we say linear regression is appropriate. All right, I don't see a pattern here. Data is all jumbled,
Oh, 'cause
disorganized.
if there's a pattern, you would be able to look for the actual line through it.
Oh, I get it.
If there's a pattern, it means that the line that you're using, yeah, it means that some other curve would have probably fit it better.
Or there just is no curve.
Or there just is
Oh,
nothing.
because it would have been like exponential or something.
Exactly.
That's cool.
All right, this is one of those things like, if they allowed for the course to expand upon this topic, you'd see exactly why this was useful. But since we stop it here, you're like, wow, that's anticlimactic. That's like a weird way to end the course. That's a standalone topic that doesn't seem to go anywhere. It actually goes in a lot of places, it just, you're not gonna get there in this course. So wait 3.5 years and you will, you know, it's, exactly, which is why they're probably taking it out of the curriculum within the next couple of years. But
To learn, but like, it's not in algebra.
if the conclusion to this was something that you would learn next year, I would say yes. But since you gotta wait 4 years, I mean, why? Like you'll have already forgotten it, you know?
Instead of having